Welcome to the second video in the Unnamed Project series. Video number 1, we talked about data and how data underlies basically every video game that we play. This time we're going to talk a little bit about generating a universe. There's two ways to essentially go about generating a universe for a game such as this. The first is to manually place everything, whether it's a star system or a planet or a space station. The second is to allow the system to generate these for you. I'm opting for option number 2, mainly because this kind of game really benefits from having the board change itself up every time you decide to play a new game. If the map were static and all of the stations and systems were in the same place, it would probably be the replayability value, at least for me, would probably be very low. So we need to talk about how we're going to go about doing that. There's, I've kind of oversimplified it, really, but for my purposes, it seems to work pretty well. There's 4 different methods that I've got going on right now, which contribute to the creation of a universe. So when you select a new game, we run this method called, in the Big Bang, called Bang It Creative. And what this does essentially is 4 things currently. We generate the universe, meaning we place the solar systems in 3D space. We generate stellar bodies, which are the planets, in one of 4 different zones, either the rocky, habitable, gas, or ice zones. We stock shells by assigning commodities and quantities to different stations, and then we assign stations to orbit planetary bodies. So to generate a universe, essentially we take a volume, which in this case is a rather large cubic volume mass that comprises the game world. We divide it up into smaller blocks, and there is a chance that a solar system could randomly be placed into one of those blocks. We can't place a solar system into every block because then the visuals would essentially look like a gigantic cube which has solar systems evenly spaced from one another in a nice 3-dimensional grid pattern. So doing math, we randomly select these blocks and we place solar systems in them by creating coordinates, by randomly choosing coordinates in 3D space. As we do this, we store it in our game state database by creating these shadow objects, the meta data objects, which are associated with data from our static database. So the meta objects change as gameplay progresses, but the static data does not. So we need to have these 2 different buckets. Game state is what's saved when you hit save game, and it's what loads when you hit load game. Pretty simple. Once we've created our solar system, we need to assign stellar bodies. Now, I'm not really basing this on hard science. I did do a little of investigation because I wanted to get a little bit of realism, or at least based on, astrophysics theory or something. So in order to generate stellar bodies, we need to take into account that there may or may not be a theoretical habitable zone. So based on the star type that we have assigned, certain star types have greater chance of having habitable zones than others. So based on these theoretical percent chances, we create stellar bodies anywhere between 0 and 12 in each system. And we generate a stellar body of different types. We have a rocky zone, and we have the potential to have habitable zones. And then we have gas and ice zones. So this whole method here essentially kind of nicely randomizes. It's not entirely random. It's actually kind of hokey, but it works for now. This needs to be refactored and probably thought out a little better. But again, these objects are meta objects, and therefore they will be actually these These are not meta objects. We are generating these entirely on the fly, and we are putting them into the game state database, because every time we generate a new game, we want not just new systems, but new planets. Once we're done with that, we can create our, we can assign our space stations. The space stations currently have values in the static database, so we are creating meta objects for the stations, because the stations need to know how much inventory for each commodity they have. In this case, we're randomly creating anywhere between 0 and 2,500 units of each commodity at each station. Once we have that, then we can assign our stations to random planets. For each station meta object that we have, we choose a random stellar body from somewhere in our game state database, and we assign the station to orbit that stellar body. This means that some systems may have no stations and some systems may have multiple stations, but that's kind of okay because we want to ensure that things change up and that nothing is predictable if we can swing it. A lot of this needs to be refactored and expanded. For example, habitable stellar bodies would probably have a much higher chance of having a station than ice planets, for example. So we definitely want to take that into account when we're generating a system. So what does generating a system look like? The first pass that I made here, once the system has been generated, I threw essentially all of the systems down into onto the map, and we kind of left it at that. Here's an example of what I've got. Now, these objects here, stars A, B, F, G, K, M, and O, represent the different types of stars. And I've taken this off of a stellar chart. It is not really scientifically accurate, but it's accurate enough for our purposes. So each star system here is represented by a color and a size. And this is using Unity's built-in particle system, so it's not final. It's placeholder and for reference purposes only. So each different type has a temperature, which dictates its color, as well as the size of the star. This guy right here, G, this is us. This is the sun. So the static database has references for each of these star types. So when a G-class star is generated and rendered here on the screen, we will get this particular prefab, and so on and so forth. So our universe, the first time I did it, had a couple hundred different representations from this selection here all over the place. And that was okay, but it's not what I wanted. A long time ago, the game Trade Wars, which is what I'm basing a lot of this on, serving as an inspiration, had limited visibility. When you were in a sector, you could only move to certain other sectors. And usually you might see this in a space simulation game by a sector having jump gates. This is a kind of a mechanic that kind of limits you to where you can go, where you can travel to. Jump gates will only allow you to travel from System A to System B, but not to System F. If they installed a jump gate that allowed you to go from System A to System F, you could go. Basically, if you think about it right now, that's kind of silly. It is and it isn't. I mean, the conceit of the jump gate is that it creates a small wormhole. So connecting point A to point B requires a jump gate. If you have a ship, however, that is capable of faster than light travel, it stands to reason that you should just be able to go anywhere that you can reach. So I wanted to do that. In Trade Wars, for every sector that you entered, you only had a limited number of sectors that you could exit to. In this case, what I wanted to do is twofold. One, you have a scanner on your ship, which only allows you to see a certain distance from the sector that you're currently in. And two, you may be able to see a sector, say, 100 units away from where you are now, but if your jump drive can only take you 50 units, then if you can see 100 units, but your jump drive can only take you 50 units, you won't be able to reach all of the systems that you can see. You'll only be able to travel as far as your jump drive will carry you. In order to do that, I wanted to arbitrarily limit the number of systems that the user could see at any time. So, in order to do that, we had to come up with a system whereby we would generate systems based on the distance dictated by the scanner that you have. So I've already got a game generated, so we're just going to load a game here, and we're going to see what it looks like. So right here on this system, we have a case where our scanner is set to 100 units. So essentially our current system, which I think was this guy right here at the center, we can see other systems which are 100 units or less away from the current system that we're in. Now, at this point, what we'd assume is that we have a jump drive which could take us 100 units away. So we could essentially travel to any one of these particular systems based on the jump drive that we have. So in order to do so, what we do, let's say we'll travel to this guy right here, this little pink one. And what happens is, I gotta get the camera moving. So when we click on this guy, our view changes. So now we're looking at all of the systems that are within 100 units of the new system that we've just traveled to. Now, I don't have user interface set up to indicate what system we're currently in or what system we just came from, but that's next on my list. So what we've got is, let's say we crank this down to 50, and we'll click on this guy right here. So now we're only seeing systems that are within a unit range of 50. So as you can see, it's significantly fewer. And I would assume that this would be kind of like where you would start off. You'd start off with your starter ship that has a scanner with a very low range, as well as an engine jump drive which has a very low range. But this is going to essentially be the game universe. You will leapfrog from visible cluster to visible cluster. The reason being is that if you could see the entire universe, 10,000, for example, what you would see is this. In this case, if you were in one corner of the solar system, down here, one corner of the universe, and you could see somewhere on the opposite side, well, you could essentially just click to go there, because why not? We're not using jump gates. If you could see it, you can travel to it. So instead, what we have to do is we have to limit it some way. This way, you could essentially mouse over everything, click on everything, get all kinds of detailed information, and make decisions really, really quickly, thereby reducing the exploration portion of the game to something incredibly insignificant. Instead, you're going to have to travel to each system, and you're going to have to move from system to system, figuring out, is there a station here? What are they buying? What are they selling? Is there anything interesting here? Am I on good enough terms with this faction to be able to get into this system? What are the conditions in this system? Is it lucrative for me to stop over in this system, or should I just pass on through? There will be mechanisms which will help to get information on further systems that are further out. I'm still debating whether or not I want to allow for something like an autopilot based on systems that you've already visited, or to retain the visibility of a system you've already visited, so that essentially you're uncovering star systems as you travel. I still think in the end you would end up having kind of a disaster area where every system is essentially visible and you would be able to just click and go anywhere. Who knows? I don't know. I haven't quite gotten that far. But more or less, this is what we've got for the generation of a universe, and how the game is intended to work as far as travel and visibility goes. So hopefully in the next video I will have some examples of some of the user interface options that I want to include, and if I get a chance, maybe some updates to the how the universe is generated, because I know that's kind of a disaster as far as needing to be refactored.